Here you see the result of my first attempt to mount a camera in an aircraft to record a flight. Unfortunately, the engine vibration got transmitted to the camera, and that resulted in blurriness of the image, which made it unusable. Now, the camera I was using was a Micro Studio camera by Blackmagic Design, and the reason I chose this camera was first that it was equipped with a lens that had an iris, which allowed me to better control the shutter times and exposure. And second, it has a narrower field of view than most action cameras. The field of view of this camera equipped with a 12mm lens is 57 degrees in the horizontal and 34 degrees in the vertical. Most action cameras are quite a bit higher than that. So the original mount was pretty simple. Just two pieces of angle aluminum attached to the center windshield brace. It was very rigid, just not rigid enough to keep the camera from tilting and blurring the image. This is a simplified 3D model of the Micro Studio camera with the stock mount on top here and on the bottom here. Now, the aim of this project is to not mount the camera completely rigid in the aircraft. That four-cylinder Lycoming engine does produce quite a bit of vibration, and I want to isolate that camera from most of that vibration. So I am going to mount it on rubber shock mounts, but at the same time, I want to avoid the camera have any angular freedom, because that angular tilting motion you see here is what caused the image problems at the beginning of this video. I do want the camera to be able to move up and down, not as much as shown here, but just slightly, maybe 1 or 2 thousandths of an inch. And that'll take care of most of the engine vibrations. To find the best solution, let's look more closely at what causes the angular movement of the camera. So again, shown here in red are the two camera mounts, and this is the center of mass of the camera lens combination. Now ideally you want the center of mass to be located in plane with the camera mounts, but in this case it is located quite a distance forward of the mounting plane, and that distance introduces a moment or torque on the camera mounts, resulting in the pitching motion of the camera. The best way to prevent that pitching motion is to introduce a third mounting point located on the flange where the lens attaches to the camera body. And now the center of mass is located between mounting points, and the pitching motion of the camera is largely suppressed. So luckily the time and effort put into building the original camera mount wasn't wasted completely, because now I have the position the camera needs to be in to avoid interfering with the aircraft's windshield and the windshield brace. It also gives me the angle the camera needs to be pointed at to center the aircraft spinner in the field of view of the camera. Now, of all the tools available to me, the best one to transfer those measurements into the computer is actually my 3D laser scanner. So here I'm scanning the camera installation with the original camera mount, and then I'll get a 3D model I can import into my CAD program and take all the measurements I need. So here's my 3D scan imported into SolidWorks. And first of all, what I can do with the scan geometry is I can model the center brace of the windshield, and it's right here. And next, it allows me to position my 3D model of the Micro Studio camera correctly, just like it is in the airplane. And so this is here now. And now I can turn the scan off. It just kind of distracts. So here's the center windshield brace and the camera positioned correctly relative to each other. Now, as planned, I need to introduce a third mounting point, which is positioned on the flange between the camera body and the lens. And the best material to use for that purpose I found is an O-ring. It grabs kind of the camera along its whole circumference, and also there are different hardnesses of rubber for O-rings. So in case I do have problems in the future where I have certain vibrations or whatever, I can change the hardness of the rubber and change the vibration behavior of the camera. Now with that, like I mentioned before, I have two more rubber mounts to dampen out the vibration, one on top and the other one at the bottom. And now I can use all that geometry to build a cage around the camera that doesn't interfere with the camera body, the lens, the windshield, or the windshield brace. And that would look like something like this here. And I can check and make sure it doesn't interfere with any parts by slicing through the whole installation. Everything looks good here. You can nicely see here the O-ring captured in the camera mounting cage and pushing against the flange on the camera. I can also check it from side to side. Yeah, everything clears, everything is good. So now this cage around the camera just needs to be mounted to the center windshield brace. So I have those 4 screw holes, and I'll have a second part, the clamping block. I use 4 Allen head screws to mount the camera mount to the windshield brace. This is the installation of the finished camera mount in the aircraft. Now the lens shown here is a 12mm fixed focal length lens. On the original installation I used a zoom lens, but I was able to determine that the 12mm setting worked best, so I went to a fixed focal length lens. Now the Micro Studio camera doesn't have any internal recording capability, so to record the footage I installed an Atomos Shogun monitor recorder on the Copilot side. And that worked out pretty well because I could monitor exactly what the camera was seeing and monitor all the camera settings through it. If you're interested in watching the footage I shot using this installation, check out the skies over Palo Duro Canyon on my channel. And if you're interested in how I machined the mount, there's also a machining video that shows the steps I went through creating this mount.